Hello, this is Mark Chima with the SICK Automotive Group, and what I wanted to show today is the use of the SICK MLG light grids to do error proofing. So what we have in our example here, in our demo, is we have a SICK MLG light grid, sender receiver in the X direction, and an MLG light grid sender receiver in the Y direction. And basically what we're doing is the light grid is set up for 10 millimeter beam spacing. So in other words, between each one of these beams is 10 millimeters. So you have these beams that are coming across in the X and beams that are coming across in the Y, and the spacing is 10 millimeters. And what happens is when an object goes in, it breaks the beam, and then you can tie that beam broken to an output so you know exactly where it's at. So on this demo here, this particular model of MLG, we have 3 outputs from the X and 3 outputs from the Y. On the newer ones we have 6 outputs, or you could also do it analog or via a field bus. So basically you have infinite combinations of where you want to see and how many points you can pick up in the light grid scheme here. So in this case we have our bolt pattern, which is bolt 1, bolt 2, bolt 3, and bolt 4. And what we're trying to do is we're trying to error proof this application. So what we want to do is we want to make sure that the operator torques these bolts in the correct sequence, being bolt 1 first, then bolt 2, then bolt 3, then bolt 4. So what we have is we have a tool here. So when the tool goes in on bolt number 1, what it does is it breaks a light beam in the X direction. It also breaks a light beam in the Y direction. So then what we do is we take both of those outputs, the output from the X and the output from the Y. We're feeding it here into a SICK safety PLC. And again, I'm using this PLC strictly for I/O control, not in a safety function. So it's just single input in. So those outputs come into the PLC as an input, and then what we do is we turn on a corresponding output in the PLC over here. So when we're in bolt number 1, output number 1 comes on. When we're on bolt number 2, output number 2 comes on. Bolt number 3, output number 3 comes on, and we're for bolt number 4, output number 4 comes on. Any other configuration will give us no output. So it's very simple logic. All we're doing is saying that if one of the beams is broken in the X and one of the beams is broken in the Y, then we're going to send those corresponding outputs to the PLC, and we have to see both the X beam broken and the Y beam broken exactly in that spot. And then when we do, we turn on a corresponding output. So this is a very simple way to do error proofing applications, whether you're fastening a cover to a transmission, or a cover on an engine, or maybe a rear differential, or basically any operation where you need the operator to follow a correct sequence when he bolts something together. You just set up the light grid around it and error proof it. The next step is I'm going to take you into the software to show you how easy it is to set up the SICK MLG light grid as well as the safety PLC.